Okay. Looks like we're up. Excuse me. Okay. Where was I? Where was... Oh, okay. Oh, I remember now. Remember all too clearly. Reached unreachable code. Turns out, not so unreachable. Perfectly reachable. Because they forgot who'd be writing this code. Still too hot. Yeah. Okay. I may... Yeah, okay. First things first. I gotta know what the edit is. Oh, yeah. I think it's expect equal strings. Yep. Let's go p dot headers of yep. Okay, so that should print the error. Well, it's not. Oh, it's somewhere else. $2.99. Okay. Oh, it's a different test. Interesting. Where's my debugger? Yeah. Okay. Yeah. Damn. Damn. No prefix parse function found for equals. It's enough by one error. 299. I did remove parse let statement. Yep. Identifier. Expect p. Peak token is set. The current token is identifier. This is the let. Strange. What's the edit again? No prefix parse function. Okay. So it's around prefix. Yo. Hey Isabella, Henry. Nothing much. I'm trying to work on a parser. How are you doing? Not bad. Can't complain. How about you? How are you doing? No prefix. It's still early. It's only been 10 minutes. Going pretty slow, I would say. You a programmer too, Isabella? Mostly every day. Like 5 or 6 times a day. Sorry, week. Infix parse functions. Not at the moment, actually. I just got started, so I'm like, what's it called? Yeah, I don't want to take it too seriously, so that's why I've left it as it, well, left things as they are. Thank you for asking, though. And I appreciate the hustle. Hopefully you find some work. Okay. Prefix parse function. Is it prefix or infix? Prefix. Interesting. What is it doing here anyways? So parse let statement. So far I haven't called parse expression, so I call it here. Let me have a look at how Thorsten does it. Oh, hang on. I think it won't do it till later. Excuse me. So at this point, it hasn't added, because otherwise this would be the first error. Am I parsing the token correctly? Lexer. Token.assign, literal, yeah. Looks correct. So what does expect peak do again? If peak token is expected, off. Hang on. It checks the peak token. That makes sense. So I need to. The current token is still assign. Means I need to call self dot next token. I think should be a way to just expect peak. Have a look at how the book does it later. No prefix pass function found for 5. Okay. Guessing. Yeah. No infix pass function. No infix pass infix. So there shouldn't be an infix. What line is that? 641. No. Mm-hmm. 403. 403. Okay, so it was this line. Mhm. Interesting. So it's have a look at the book. I think I might be off by one again. Parse Infix. Oh no, I'm not. Left is never called. Of this might be wrong. What is P? Okay, that's the current precedence. Shouldn't this be greater? Apparently not. That is interesting. I wanted to check that. Left expression is prefix. Oh, oh no. Yeah, that's correct. Okay, left is called right here. Check if there's an operator after. Yes, parse infix, parse left, operator, parse right. Think I've done, yeah, most of it. Yeah, all of it. Sometimes my mind plays tricks on. I don't know why I'm singing that song. Why is it in my head? I have no idea. Okay. I think I'm gonna find out what's actually happening. Let me run the test again. Oh, the assertion should fail. I should maybe print. There's 2 5s. Okay, what I'll do is maybe can I forget how to do it. Okay. Okay, perfect. So there shouldn't be an infix expression. Let's have a look at let's statement. Pass the identifier and you pass expression. So you try to get prefix parse What is this? Oh, okay. Test expressions with integers, test prefix expressions. Yeah. Don't really know what that means anymore. What was I trying to say? Anywho, okay. So token type is int. Okay, pass expression. Try to get a prefix function. Token type is try token. Well, actually, we could print both. Token dot token type. What's that now? Okay. Hang on. Think tag from something like that. Zig. It's called tag name. Okay, is that it? Okay, there we go. Tag name. That should work. No infix pass function. Yeah. Fuck. That means I think this should be expect peak. No, but that will add a. Do I actually move forward? Yeah, I do. Yeah. Oh no. Okay, it's peak token. That makes sense. That's why. Forgot that I removed Okay, nice. We got it working. I can change this back. No. To 5. Okay. Let's go. Nice. Infix expressions parsed. Okay, not bad. But I do think, well, these off by 1 errors happen far too often. I guess it's part of the territory. Territory. Yeah. Okay, yeah. Now I gotta write tests for these. Test operator precedence parsing. That's fine. I don't have the string method. So I want it. Nah. We'll just have a look at. Is there another way to test precedence? Okay, I think we can think about it in the future. Think test return value, yeah. Think I can get rid of this now. Yep. Yes, sir. Maybe I can do return statement too. So return value just be parse expression. Yeah, I think so. Well, just like, yeah, I think it just needs these 2 lines. And this should be done. Turn statement dot return value. Parse expression of p. Yeah, and that's it. Statement return value. Expected return value. Yep, it's going to be expected return value. It's going to be const. Tests of I dot expected return value. Cannot assign to constant. Okay, parse return. Found AST expression. Okay, hang on. Oh, okay. Yeah. That one's easy. Where's the test? Yeah. Return value dot literal. Okay, what about that? Okay. I think it's because expression. Okay. We need testing dot allocate. No. I do have self dot not self. What am I looking for? Okay, we pass in the allocator. Yeah. Okay. Okay. Nice. Parsed return statements. Bonus. Okay. How does parsing work? Top-down operator Seedon's paper. There are differences between his and our implementation. Pratt doesn't use a parser structure and doesn't pass around methods defined on parser. He also doesn't use maps, of course. He didn't use Go. Paper predates Go by 36 years. There are naming differences. We call prefix parse functions are nuts for null denotations for Pratt. Infix parse functions are LEDs, left denotations. Okay. Formulated in pseudocode though, our parse expression method looks strikingly similar. Okay, nice. Going to skip the theory that answers why it works and just follow how it works and how all the pieces fit together. Yeah, suppose we're passing 1, 2, 3, 1 plus 2 plus 3. The big challenge here is not to represent every operator and operand in the resulting AST, but to nest the nodes of the AST correctly. But to nest the nodes of the AST correctly, what we want is an AST that serialized as a string looks like this. I wonder if there's a way to test this. The AST needs to have 2 infix expression nodes. Yeah. The AST expression higher in the tree should have integer literal 3 as its right child node, and its left child node needs to be the other expression. The second AST 1 and 2, yep. And this is exactly what our parser outputs. I'm going to take a closer look at what the parser as soon as the parse expression statement is called for the first time. It's not a mistake to have the code open while reading the following paragraphs. I remember it now. By now, I mean. Okay, so parse expression statement. So the first thing is we'll try to find a prefix function for the integer, and then it'll go further within the method of parse expression. So after you've parsed the integer by calling the prefix function, parse function, then you have a look at the next token, which is plus. And then you try to find an infix expression and you pass 1 into it as the left expression, and it evaluates left operator, so parses, sorry, not evaluates, parses the left operator and the right by calling parse, I guess, hang on. Parse the expression. Okay, so at this point this is 1. Well, here. Yeah, I suppose the current token is 1. It's going to be int 1. Makes more sense. Going to be parsed. And then goes further, tries to get an infix parse function for 2. No, for plus. Because that is the next token. I want to look at parse infix expression. I mean, I'll have to handle it at some point, so I'll ignore that. Maybe leave it there. Okay, so the current precedence. Current token is integer because we moved forward. Hang on. That isn't right. Oh yes, no, it's right, because we looked at the peak token. Yeah. Current operator, yep. And we call parse expression again. And it'll do the same thing, where 2 is now a prefix. Yeah, we'll find prefix parse function and then just keep repeating that. That is cool. That makes a lot more sense. I mean, that makes a lot of sense. That's cool. And I understand it too. Nice. Parse expressions, yeah. It's just the precedence that I've ignored at this moment. Yeah, and this whole thing becomes left for this. This becomes left, this becomes the operator, and this becomes right. So it's like nested where, okay, yeah, this becomes the left, operator, and right in this infix expression, where left is another expression with its own left and right. Okay, that's cool. I can see how it works now. That's awesome. Pretty clever. I don't know if I would have figured that out looking ahead, but in hindsight, makes a lot of sense. Yeah. Yeah. Integer 1 and 2. Yeah, this is the left half. Yeah. And then this becomes the left. Yeah, we're back in parse expression statement. Yeah, this bit too. That is a good question. What if it was like product instead of sum had the same precedence? What about different? Couldn't we just use lowest by default? Goals to have expressions involving operators with higher precedence to be deeper in the tree than expressions with lower precedence operators. When parse expression is called, the value of precedence stands for the current ripe binding power. Current parse expression invocation. Jeez, no idea what that means. When parse expression is called, the value of precedence stands for the current ripe binding power. Oh, you mean if it can go further within the same statement? Oh, okay. As in, it can be attached to the right. Oh, sorry, then it means it can be the right expression of the infix expression if the operator is of a lower precedence. Lower, or I think the same precedence. Case our current right binding power is of the highest possible value. What we passed so far is never passed to an infix. Yeah. Interesting. What if it was 1 plus 2 star 3? So you'd go along, all of a sudden you see a star. What happens? Parse expression. Interesting. Kind of looks wrong there. I mean, from what I've done. From our call to peak precedence. Ah, yeah, actually it does make sense, because here we've passed 1. We check the next token, which is a plus. No, I don't get it yet. This condition checks if the left binding power of the next operator / token is higher than our current right binding power. If it is, what we passed so far gets sucked in the next operator from left to right and ends up being passed into the infix parse function of the next operator. Yeah, so this will become left. Yeah, the -1 makes sense to me, because this would be passed together. This would be left, so the operator, this is the right. I think it's the ones where multiplication is involved. Instead, 1 is returned as the right arm of the prefix expression. Whoa, hang on, back up. What do you mean? Okay, I think I got that bit. I don't want to confuse myself now. Which is this? Oh yeah, this is the one that I want to see. The left binding power of star would be higher than the right binding power of plus. Okay, hang on. Let me walk through this method. Currently left is 1. Peak token is not semicolon. Current precedence. is lowest. Let me have a look at pass prefix. Yep, so that is lowest, so it is less than plus, which has a higher precedence. So you get an infix parse function for plus. Every token has the same right and left binding power. But as an example, to make plus right associative, you can decrement its precedence when calling parse expression. Interesting. Okay, you actually check. Interesting. What is this? Don't remember this at all. Yeah, I'm not sure how the precedence works for a higher, when a higher precedence. Okay, I should just walk through it. So we'll take the example 1 plus 2 times 3. So you start here, you pass integer, then you check the next token, has a higher precedence. Try, you get an infix parse function. And you parse 1 and 2. I see what you mean. So you parse 1 and 2. Parse the operator. 2, you'll try to parse 2 by calling parse expression. And the current precedence is lowest. At which point you you return 2. Yeah, I'm not sure I get that. I'll come back to that later. Parser, see what happening when parsing certain expressions. In the folder of code accompanying this chapter, I've included a file called tracing. File includes 2 function definitions. Understand what the parser does, trace and untrace. Excuse me. Okay, -1 times 2 plus 3. I mean, when it's on the left, I get it. I get how it's gonna work. It's when it's on the right, which I don't really understand. Okay, extending the parser. That probably is going to be something for future me to handle. That's the below statement. Actually, yeah, but I can have a look at it tomorrow. I think, yeah, pretty good. Parse expressions. Okay, I think that's pretty good. Pretty happy with that. And I have to say, I'm getting a lot more comfortable with Zig since I started this. Interpreter book. Profound. So profound. Worth the wait. Okay. I guess that's gonna be it for me. Hope you have a good day as usual. And I shall see you tomorrow. Yeah. This was good. It was short, but I had a lot of fun. Got some stuff done. Not a lot of, what's it called, pushbacks today. Good stuff. I'll take the W. Okay. See ya.